guys, I'm Cordy.
I'm Rachel.
And I'm Simran, and we are AP Pre-Calc students at McNair Academic High School in sunny downtown Jersey City in New Jersey.
Today we're going to be talking about the transformations of quadratic functions. Now, although this might seem complicated, we're going to break it down so it's so simple, and every time you see a quadratic function, you're going to know exactly what to do.
We'll be talking about the different categories of transformations, how to understand the transformations through equations, and how to identify them on a graph.
This is the equation that we can use to describe the transformations that can be applied to the parent function of a quadratic f of x. Each variable a, b, c, and d represent different transformations that can be applied to the parent function. Let's start with a.
In the equation for a transformation, the a value represents a vertical dilation in a reflection over the x-axis. To start, the vertical dilations can come in two types, a vertical stretch or a vertical shrink. A vertical stretch is when the graph gets narrower because the value of a is greater than 1. This is what it would look like on a graph if the a equaled 2. On the other hand, a vertical shrink is when the graph gets wider because the a value is between 0 and 1. Here's what it would look like if a equaled 1/2. The last thing the a value can do is a reflection over the x-axis. This is when all of the y values become negative. This is what it would look like if a equaled -1.
In the formula, b is used to describe all horizontal dilations and reflections over the y-axis. Let's start with the reflections. If b is positive, there's no reflection over the y-axis. However, if b is negative, then there is a reflection over the y-axis. Here's what that would look like on a graph. Now for dilations. Horizontal dilations are a little trickier than vertical dilations because the stretch or shrink of the graph is done based on the reciprocal of b. For example, over here, b equals 3, meaning there's a dilation of the graph by 1/3. Another tip is make sure that your horizontal dilation and reflection are stated in factored form rather than unfactored form. Unfactored form would look like b times x plus or minus b times c, while factored form would look like b parentheses x plus or minus c.
In the equation above, the letter c represents a horizontal shift. The sign in front of the horizontal shift can be a little bit counterintuitive. The equation has in parentheses x minus c. So if c is negative, it's actually x minus negative c. That would be a translation left, and it would look like x plus c. If c is positive, it represents a shift to the right, and the final equation would say x minus c. Obviously, if c is 0, the function has no horizontal translation. In that case, it would just say x inside of the parentheses. Here's an example. Because the parentheses say x minus 3, the function f of x is translated 3 units to the right.
I think the final variable d is the most simple, dealing with vertical translations up and down. To put it simply, if the d value is positive, the function is moved that many units up, and if the d value is negative, it's shifted that many units down. This is an example if the d value is 5. As you can see, the function is moved 5 units up.
The last thing we'll talk about is non-rigid versus rigid transformations. Rigid transformations maintain the shape and size of the function, which includes translations, rotations, and reflections. On the other hand, non-rigid transformations change the size of the function but maintain the same shape. An example would be a dilation, either horizontal or vertical.
For a function like this, you would list the transformations as you see them from left to right. So let's start with the a value. This function is reflected over the x-axis as there's a negative sign before the a value and has a vertical dilation by 5. Next is the b value. Because it is positive, there is no reflection over the y-axis. However, since it is 3, there is a horizontal dilation by 1/3. For c, since the inner parentheses say x plus 4, that means there's a shift to the left by 4 units. Finally, since d equals 2, the function is shifted 2 units down.
Here you go.
And there you have it.
Cordy, why would you do that?
And there you have it. Here are all the transformations of f of x.
For this problem, we're going to use the transformations given to write a new equation for the parent function. Let's first remind ourselves of our original equation, g of x equals a times f parentheses b parentheses x minus c close parentheses plus d. For the first variable a, we know that it's going to be a vertical shrink, which means a is going to equal 1/2. For b,
because it's a reflection over the y-axis, b is going to be negative. And for the horizontal stretch, we use the reciprocal of the factor, meaning that it's going to be 1/3. So b equals negative 1/3. Then, for the horizontal shift, by 2.5 units to the right, if it's to the right, we know that the number is going to be negative, so c equals negative 2.5. And finally, for the vertical shift d, it's up 5 units, so it's positive 5. This means our final equation is g of x equals 1/2 times f, open parentheses, negative 1/3, x plus 2.5, close parentheses, plus 5. Don't forget to add the exponent of 2 because the parent function is x squared. And that's the final answer. Now it's your turn to try. Pause the video and try to write out all of the transformations for this function. Okay, now here's the solution. There is a vertical dilation by a factor of 2, a horizontal dilation by a factor of 1/4, a horizontal shift 7 units to the left, and a vertical shift 16 units up. And that's it.
Here's a quick recap of everything we learned in today's video. We learned about quadratic functions and how to use the variables a, b, c, and d to apply different transformations, such as horizontal and vertical strengths and stretches, horizontal and vertical shifts, as well as reflections over both the x and y axes.
We also learned about rigid transformations, which are additive, meaning that the function keeps its shape. On the other hand, non-rigid transformations are multiplicative, meaning that the function changes its shape.
We also learned how to graph these transformations from their parent function.
And that is great job! And that is all you need to know about transformations of quadratic functions.
And that's all for our video. Hope you like it, Miss Carter.